Hello children, in this chapter we will learn acids, bases and salts. This is of class 7. Class 7 chapter. In previous chapters we have learned materials and materials are classified into groups based on their properties. Solute dissolves in a solvent to form a solution and many substances are soluble in water. But in this chapter we will learn acids, their properties and their uses, bases, their properties and their uses, and different type of indicators, salts and their types. So let's get going. We have learned about the 4 main tastes that our tongue can senses. Have you tasted the different food in the pictures? What taste does each food have? Write your answer in the space provided. You can see the picture and write answer. Different food have different tastes. For example, sugar and jaggery make food taste sweet and salt makes food taste salty. The taste of food depends on its chemical composition based on their chemical nature. Substances can be categorized into acid, base and salts. Generally, acids in food cause a sour taste and base causes a bitter taste. Let us learn more about these substances. Acids. Foods such as lemon, orange, grapes, apple, tamarind and curd are sour in taste. This is due to the presence of substances in them called acids. Substances that contain acids are called acidic substance. The word acid comes from the Latin word acers meaning sour. Figure 5.1, you can see here the picture of curd, tamarind and tea. These are common acidic substances. Now, types of acids. We will learn the types of acids. Organic and mineral acids. There are 2 types of acids, organic acid and mineral acids. Based on their sources, acids may be of 2 types, organic acids and mineral acids. Acids that are found occurring naturally in plant and animals are called organic acids. Some organic acids and their sources are listed in 5.1 table, this table. You can see here lactic acid sources is milk and curd, oxalic acid tomatoes, tartaric acid tamarind, citric acid lemon and oranges, ascorbic acid amla and guava, acetic acid vinegar, malic acid apple and formic acid ant sting and netting sting. These are some common examples of organic acids and their sources. Now, acids that are derived from inorganic sources are called mineral acids. We use many mineral acids in the laboratory like sulfuric acid H2SO4, hydrochloric acid HCl and nitric acid HNO3 are a few examples of inorganic acids. Now we will learn strong and weak acids. Based on strength, acids can be of 2 types, strong and weak acids. Highly corrosive acids that cause severe burn on coming on contact with the skin are called the strong acids. Most mineral acids such as sulfuric acid, hydrochloric acid and nitric acids are strong acids in their concentration form. Due to their corrosive nature, most strong acids react with metal. So these are stored in a glass bottle. This is the reasoning questions. Why strong acids are kept in glass bottle? Acids that are not as corrosive as a strong acid are called weak acids. All organic acids such as citric acid and oxalic acid and some mineral acids such as carbonic acid are weak acids. Now, concentrated and dilute acids. Based on the amount of water present in their solutions, acids may be classified into dilute acid and concentrated acids. A solution of an acid that contains a small quantity of water is called a concentrated solution. A solution that contains a large quantity of water are called dilute acids. Adding more water to the concentrated acid can make it dilute. Evaporating water from a dilute acid can make it concentrated. Most acids used in the laboratory are diluted with water because their concentrated form can be too dangerous to handle. Remember, never pour water onto the acid or base in a flask. Doing so releases a large amount of heat and the corrosive mixture may splash onto your body. So keep remember. So now we will learn properties of acids. Some properties of acids are given below. Acids are sour in taste and are soluble in water. They turn blue litmus paper red. Acids are corrosive in nature. They can cause burn on clothes and skin. They can also damage other materials such as certain metals. This is why acids are stored in a glass bottle. Acids react with metal to form salt and hydrogen gas. These are reactions. You can see here the reactions. First one is acid react with metal and to form salt and hydrogen gas. You can see here zinc is a metal reacted with hydrochloric acid HCl and it's formed zinc chloride and hydrogen gas. Next reaction, acid react with carbonates to form salt, water and carbon dioxide. So you can see hydrochloric acid reacted with calcium carbonate. So calcium chloride, water and carbon dioxide. You can see the reaction here. And next one, acid reacts with bases to form salt and water. So sodium hydroxide base is reacted with hydrochloric acid, formed sodium chloride plus water. You can see here the reactions. When you are writing the reactions, you must need to write like this reactions and with balance reactions. And science in action means real life. You can see fossil fuels such as coal, petrol and diesels contain carbon, nitrogen and sulfur compounds. When these fuels are burned, gases such as carbon dioxide, nitrogen dioxide and sulfur dioxide are released and pollute the air. These oxides react with rainwater to form acid. Carbon dioxide form carbonic acid H2CO3. Nitrogen dioxide form nitric acid HNO3 and sulfur dioxide forms sulfuric acid H2SO4. This acidic rainwater fall on the earth as acidic rain. Now we will learn uses of acids. What is the use of acids? Some uses of acids are given below. Sulfuric acid is used in a variety of industrial products such as fertilizer, detergent, dyes and other chemicals. It is also used in car batteries. Sulfuric acid is used in car batteries. And other one, hydrochloric acid HCl is used in the processing of steel. It is also used to make household cleaners. And nitric acid. Nitric acid is primarily used in manufacturing fertilizers such as ammonium nitrate, explosive, dye and plastics. It is also used in the purification of gold. So purification of gold, we are using nitric acids. Carbonic acid is used to make aerated drinks. You can see in this figure. Acetic acid is used as vinegar to give a sour taste to food. It also acts as a preservative. Several acids are used in discoloring, removing salt deposit form when water is heated. Equipment such as kettles and water heater. Ascorbic acid occurs naturally as vitamin C in citrus food and fresh vegetables. It helps keep our skin and gums healthy, in healing of wounds and in the maintenance of our bones and teeth. Now, base. Substances such as toothpaste, soap, baking soda and shampoo are bitter in taste and soapy to the touch. These substances contain base and they are called basic substances. You can see here toothpaste, soap and baking soda. Then how many types of bases and their properties? Like acid, bases can be of two types, strong and weak. Strong bases and weak bases. Example of strong bases are sodium hydroxide NaHO3 and potassium hydroxide KOH, and weak bases are not as corrosive as strong bases. Magnesium hydroxide MgOH2 and ammonium hydroxide NH4OH and copper hydroxide CuOH2 are a few examples of weak bases. Now we will learn the properties of bases as like acids. So some properties of bases are given below. Bases are bitter in taste. They feel soapy or slippery to the touch. They turn red litmus paper to blue. Some bases, but not all, can dissolve in water. Bases that dissolve in water are called alkalis. Keep in mind, bases that dissolve in water are called alkalis. Sodium hydroxide NaOH and potassium hydroxide KOH are example of alkalis. Like acid, bases are corrosive in nature and should be handled with care. Bases react with certain metals such as just zinc and aluminium to form salt and hydrogen gases. So you can see here the reactions. Zinc plus sodium hydroxide formed sodium zincate and hydrogen gases. This is the reaction. Bases react with acids to form salt and water. So ammonium hydroxide base reacted with hydrochloric acid, formed ammonium chloride and water. This is the reaction. NH4OH plus HCl formed NH4Cl. This reacted with this and HOH is here form water. Now uses of bases. Some of uses of bases are given below, like a detergent and antacid. So, sodium hydroxide is used to make soap. Sodium hydroxide is used to making soap, detergent and drain cleaner. Magnesium hydroxide is used to an antacid called milk of magnesia. An excess of naturally secreted hydrochloric acid in the stomach causes discomfort. A condition are called acidity. An antacid reacts with the acid to form salt and water, thus relieving the symptoms of acidity. Ammonium hydroxide is used in making fertilizer and household cleaning agent, and calcium hydroxide is commonly known as slaked lime. It is used in making cement, bleaching powder and fungicides. It is also used in the treatment of the water waste and effluents. What is effluent? Effluent is a liquid waste usually released in the large quantities into a water body, given out by industries and neutralizing acidic soil. Potassium hydroxide, also known as potash, is used in alkaline batteries and manufacture fertilizer and soft soap. Now we can see here practical skill handling acid and bases. You can see the picture how we are handle acids in the laboratory. You can see always handle bottle containing these chemicals with care and making sure to wear safety gloves like this. If you accidentally spill some chemical, pour water over area to dilute the chemical. And always wear a lab coat to protect the body from coming in contact with acid and base. And always wear safety goggles while handling chemicals. Safety goggle protect fumes of chemical from getting into our eyes. So this is the protection when you are doing some work in laboratory. Now, natural substances. Some chemical substances are neither acidic or nor base. They are said to be neutral in nature. An example of neutral substances is common salt. Common salt, NaCl, is a neutral substance. Now we will learn about the pH value. What is pH value? The strength of acid or base is measured on the scale are called pH. So this is the important. What is pH? pH is the strength of acid or base is measured on a scale are called pH scale. The scale is graded from 0 to 14. A solution with a pH of 7 is considered neutral. So water is a neutral because water pH value is 7. Solution with a pH of less 7 are considered acidic, and those with a pH more than 7 are alkaline. So always remember, pH value is less than 7 is acidic in nature and pH value is more than 7 is alkaline. You can see here the different of product and their chart and their pH value. Now we will learn what is indicators. We cannot taste every substances to identify whether it is acidic or base. Therefore, to taste the nature of an unknown substance, we use indicators. An indicator is a substance that help. An indicator is a substance that helps us to identify whether a given solution is acidic or base or neutral with the help of a change in color. A small quantity of an indicator is added to the substance being tested to observe a change in color. The indicator does not affect the nature of the substance being tested. Based on the source, indicator can be of two types, natural or synthetic. In real world, the color of the flower of the French hydrangea varies with the pH of the soil. In strongly acidic soil, pH below 6, flowers turns blue. In alkaline soil, pH above 7, flowers turns pink or even red. A slightly acid or neutral soil, pH 6 to 7. Flowers that are purple or a mix of blue and pink may appear on a single plant. Thus, French hydrangeas act like living indicators of soil pH. Now, natural indicators. What is natural indicators? Indicators obtained from natural sources are called natural indicators. Litmus, China rose, red cabbage, and turmeric are a few natural indicators. What is litmus? Litmus is an indicator that is commonly used in a school laboratory. It is purple dye made from organism called lichen. You can see the picture. Purple litmus solution turns red in an acidic solution and blue in a basic solution. Litmus is often used in the form of blue and red paper stripes. Acids turn blue litmus paper red, while bases turn red litmus paper to blue. And what is China rose? You can see the picture of China rose is also an indicator. Petals of a China rose of hibiscus flower are used to make a juice that is used as a natural indicator. To make the indicator, fresh petals are left in warm water for some time until the water acquires a pink color. The indicator turns dark pink, magenta in a acid and green in a base. And what turmeric is also a natural indicator. Turmeric or haldi is a common indicator used in Indian dishes. It can also be used as a natural indicator. Turmeric solution is yellow in color. Its color remains yellow in acidic and natural substances but changes to break red in basic solutions. And red cabbage. Red cabbage is also a natural indicator. Juice obtained from the red cabbage is also used as an indicator. You can see the figure 5.15 or 16. This indicator juice obtained from a red cabbage is also used as an indicator. 5.1, you can see red cabbage. This indicator is purple in color. It changes its color from purple to red in an acid and from purple to green in base. So this is also a natural indicator. Testing acid and bases with the cabbage indicator. So you can see here also. So here one activity to identify a solution, an acidic base or neutral using red cabbage solution as an indicator. Materials required: a beaker, dropper, some boiling water, mortar and petals, a strainer or dish with a lid, some leaves of red cabbage, 3 test tubes, vinegar, baking soda and common salt. What is the procedure? So you can see the procedure, step 1, 2, 3, 4, 5 procedures are given here. You can see and read, and what is the observation and conclusions. You can see here this activity you can see and can do at home also. And now we had learned natural indicators, and other one is synthetic indicators. Indicators that are synthesized by human beings in laboratories using chemical are called synthetic indicators. Phenolphthalein and methyl orange are a few synthetic indicators. Phenolphthalein indicator is a colorless solution. It turns pink in basic solution but remain colorless in acidic and neutral solution. And methyl orange is an orange colored solution. It turns red in acids and yellow in base solutions. So this is the synthetic indicators you can see. And what is the universal indicator? Now we will learn what is the universal indicator. Universal indicator are the mixture of different indicators that gives a different color for different pH value. These indicators are available in the form of strips or paper called pH paper. Universal indicator, we can test the pH paper. The color obtained when a few drops of the solution are added to the pH paper strip is compared with a standard color chart to estimate the pH of the solution. You can see here 5.19 pH paper strips with standard color chart. And now we will learn salt. Before we have learned acids and base. Now we will learn salts. An acid react with a base to the form of salt and water by a reaction called neutralization reaction. So an acid reacts with a base to form a salt and water by reaction called neutralization reactions. The acid and the base neutralize the properties of each other. Heat is also produced during the neutralization reaction. A general neutralization reaction is represented as follows. Acid and base reacts with each other and form salt and water plus heat. The reaction between sodium hydroxide solutions. So you can see NaOH, sodium hydroxide solution, is a base, and HCl, hydrochloric, is a acid solution, is an example of a neutralization reaction. And we will get NaCl salt. This is the common salt, NaCl. In this reaction, sodium chloride, common salt, and water are formed as product with the evaporation of heat. And how many types of salts? So we will learn about the salts. There are the three types of salts: acidic, basic, and neutral. Acidic salts, when a strong acid react with a weak acid, the salt formed are acidic in nature. The solution of each salt has a pH lower than 7. For example, ammonium chloride NH4Cl is an acidic and salt formed by the neutralization reaction between the strong acid hydrochloric acid HCl and the weak base ammonium hydroxide NH4OH. So when strong acid react with weak base, we will get the acidic in nature. We can identify this from the observation of pH value. And basic salt, when a strong base reacts with weak acid, the salt formed is basic in nature. Which is strong, we will find the salt that nature is strong nature, which is So formed in a strong base. The solution of such as salt has a pH higher than 7, because pH value is higher than 7 is, that means it's alkaline, or you can say basic in nature. For example, sodium acetate CH3COONA is a basic salt formed by the neutralization reaction between the weak acid acetic acid CH3COOH and the strong base sodium hydroxide NaOH reacts, and we will get the strong base in nature. That means higher than 7 pH value. And what is neutral salt? When a strong acid reacts with a strong base, strong acid and a strong base, the salt formed is neutral in nature. The solution of such a salt has a pH of 7. For example, sodium chloride NaCl is a neutral salt formed by the neutralization reaction between the strong acid and strong hydrochloric HCl and the strong base sodium hydroxide NaOH. Some salts are given here and their uses you can see here. Sodium chloride NaCl used to add flavor to food and as a preservative, and sodium carbonate Na2CO3 used in washing soda, that is used in detergent, and sodium bicarbonate NaHCO3 used in baking, antacid and fire extinguisher. Potassium nitrate KNO3 used in making gunpowder and fertilizer. Calcium carbonate CaCO3 used as marble for flooring and statues in making cement. And copper sulfate CuSO4, this is used as a copper sulfate CuSO4 used as a fungicides. Here is one more activity you can see to perform a neutralization reaction. You can see here material required and procedure is also given. What is observation, conclusion. You can see the activity and you can try it. And after that, this is the some knowledgeable questions. After that, neutralization in everyday life, treatment of indigestion. So neutralization in everyday life, what is the treatment of indigestion? Indigestion may be caused by too much hydrochloric acid in the stomach. Antacids such as milk of magnesia, magnesium hydroxide, and baking soda, hydrogen carbonate are used to neutralize the excess acid, relieve the symptoms of indigestion. Treatment of ant bites. The bite of an ant inject formic acid into the skin, which can be painful and causes the affected area of turn itchy, red and inflamed. The acid is neutralized by rubbing moisture, baking soda, sodium bicarbonate and calamine solution containing zinc carbonate or even toothpaste on the area. Treatment of soil. Soil that is too basic or too alkaline is not good for growing crops. Using excessive fertilizer can make soil turn acidic. Acidic soil can be neutralizing using slacked lime or quicklime, which is a base. If the soil is too basic, organic matter is added to it Acids released during the decay of organic matter get added to the soil and neutralize the excess of basic substances. Treatment of wastewater. Effluents released from factories from contain acid substance and can change the nature of soil and water, thereby affecting living organisms. Slag, lime, or calcium hydroxide is often used to neutralize the acidic substance in the effluent. You can see here effluent releasing from the factory. And now you can see here the concept map of this chapter we have learned. You can see acidic example ammonium chloride and all. You can see carefully the concept map. After that keywords are given: acid, base, alkaline, indicator, neutral substances, pH scale and neutralization. So you need to learn these keywords also. And the summary of this chapter you can see here. And this is the practice zone. Practice questions are given here. You see the questions and try to attempt this. Read carefully the lesson and try to attempt these questions. So this is the lesson acids, base and salts.